welcome everyone in the another session of DataHour. Okay, this session is completely full of the actions and the learning part. You can ask your any question in the Q&A sections if you have any question. Okay, and those who are new here and joining the first time in the DataHour session, I want to let them know that this DataHour session is completely a series of webinar which is conducted by Analytics Vidya, so that they can teach you data science in a fun way. Okay, so you can visit our website for the more details, or we will share the link in the chat box. Meanwhile, I am going to handle the session to Mr. Jayesh, who is going to take this session forward. He is the trainer for the today's session. And today agenda is the visualizing data set using Python. Okay, so Jayesh will move further on this regard. So hello Jayesh, I would like please introduce yourself to our participants.
Hello, hi all. I hope everybody is doing fine, having good time, learning great things. Can you please share the data set? Let me start the session. You will automatically able to see which data set we are going to use. So no need to worry. And the Jupyter notebook I will be sharing, and even I will also share the link to the Jupyter notebook in my GitHub profile. So you can also download it from there itself.
Guys, at last we will share all the details and all the links, so stay tuned with us. Okay, we will share all the details at the last. Okay, so please just you can proceed forward.
Can you enable my screen sharing, please?
Yeah, sure. Harshpal, could you please enable the screen sharing? I think it's fully provided. Yeah. Just I think you can share the screen now.
Yeah, give me a second. Yeah, okay. So is my screen visible to all?
Yeah, Jesh, I can see your screen.
And the code snippets that are written, that is also visible to all, right? Or should I zoom it more?
I think you should zoom it little more.
Okay, great.
Yeah, now
so yeah, thank you. So guys, in this session, we will be talking about plotting of data in Python, right? And why we should plot the data, what is the importance or what is the significance of plotting this particular data. Am I not audible?
You are audible, yes, I can hear you.
Okay. Maybe then Jockey, you should check your speaker or something, right? So yeah, in one of the previous session in data hours here in Analytics Vidya itself, I talked about EDA, exploratory data analysis, right? So in EDA, basically there are three major tools that we generally use in a data science industry. First of the two are Numpy and Pandas. Pandas basically used for data manipulation or making your data ready for your machine learning algorithm, right? And Numpy we generally use for playing around the arrays or basically all the high level libraries like TensorFlow and PyTorch, all those works on Numpy itself. So this session is kind of in continuation with that particular session. In this session, we will be discussing about plotting and visualizing the data, right? If I get that, I got the data from my client or my customer. Now I have to develop, let us suppose now I have to develop a data analytics solution, or in that data analytics solution, you can use anything, a machine learning or deep learning, right? But before moving on to that particular part, first of all, you need to know about your data, right? Because if you are not familiar with the data, if you don't know about your data, it will be impossible. No matter how powerful algorithm you are going to use, it is impossible to find or create a solution. So data visualization kind of comes into picture in the very initial step itself, in our exploratory data analysis step, right? And it is basically the representation of data using some of the common graphics, charts, plots, different type of plots, line plots, pie chart, or you can say heat map, distribution plots. All those things we are going to discuss in today's session. And also with the plotting or with this data visualization, you can also tell different types of stories that is related in that particular data set, right? You can build a story between the features and target variables, right? Features in machine learning language, if we talk about features and target value is the basically the value that we are going to predict by our ML or DL model, right? And feature values are the you can say are kind of input that we are going to provide to our model. So by visualizing the particular data set, we can tell different types of stories about these features and target variables, right? And also you are able to communicate complex data relationship if some of the relationship is present in between different features of your data set. I guess someone has their hands up. Yeah, Subramaniam, you want to talk, or what is your question? You can write in the chat box. We can answer later, right? Alicia is can we get a recording of video? Yeah, or those I guess Analytics Vidya will be able to provide. So now, if you guys have any question, just put it in the chat box. We will discuss that later in the session itself. Now let's start our session. It's our hands-on coding itself. So first of all, we will be talking about Matplotlib, the very basic library used for plotting in Python. All the other libraries that are used nowadays for plotting purposes, just like your Plotly or Seaborn, all those are built upon this Matplotlib itself, right? So it is the first, or you can say very basic library for plotting purpose that is present inside your Python system. So first of all, we are going to import the libraries. I'm also importing Numpy and Pandas, as I'm going to use these two libraries also at a different point in our session itself. So I'm importing Numpy, Pandas, and Matplotlib PyPlot as PLT. And if you guys know this NP, PD, and PLT, these are nothing but alias for these libraries. So that if I have to call a certain function at a particular point, I need not to write the complete name. Instead of writing the complete name, I just can write NP, PD, or PLT. And from that particular library, I can import a particular function that I need to use, right? So let's create our own data first of all. That's why I said we are not going to use any CSV file or anything. We are going to use our own data or some of the data sets that are present in Seaborn library itself, right? So here in this particular line, what I am doing, I am creating a random normal points, if you can say random. I'm using from NumPy. I'm creating 1,000 random points, and and from those random points, I'm going to create a pandas data frame, right? Whose index will be your date range starting from 7th of July, 7th of June 2019. And again, here I'm mentioning that, okay, I want 100 dates, right? For these 100 different data points. And I'm writing the name of that particular column as value. Let's see this particular cell, and let's see our data frame, how it's look like. So if you see standardized normal distribution data has been created, and that has fitted inside this data frame inside the column value. And if you see the index of this particular data frame is nothing but the date range that I have provided, starting from 7th of June 2019 and going till 1,000 days. So it is around 2nd March 2022. So if I want to visualize this particular value, right, I have 1,000 points. I want to visualize this particular value. What I can do inside your pandas itself, there is this pandas plotting that again is written upon Matplotlib itself, right? So you can just you need to just write the name of your data frame. Here it is df, right? I just write df, and after that I have just used dot plot, right? And if you see the output, you can see your data has been plotted here in a particular fashion, right? So this is basically a simple line plot for your data points that are present inside your data frame. Now let's add one more column inside this data frame, and let's name it sum. So basically this will be cumulative sum of all the values. What does this mean? Let's first of all see this particular df again. I have added this new column CumSum by adding by using the CumSum function of pandas. Now, if you see the first value of your CumSum column is the initial value that is present at the first index, right? Now, the second value will be the sum of first and the second value. Third value will be the sum of these three values. So in this way, I kind of created a cumulative sum of all the previous values, right? This particular things we generally use when we are dealing with the time series data. That's why also I have mentioned the index as a date range, right? So if you see on your x-axis itself, it has taken the index of the data frame, that is nothing but the date range, and on the y-axis it is representing these particular value points, right? Now what will happen, because in this data frame there are two columns. Now there are two columns, right? One is value and other one is CumSum. Now if I hit this particular cell, or if I run this particular code, what will be the output of this particular thing? Because initially there was only one column present, right? So it automatically gave the plot of that particular column. Now if more than one column is present, and if I run df.plot, so it will plot all the values or all the columns in one plot itself. So here you can see the blue one is representing your this value column, and the orange one is representing your CumSum value, right? And these two plots are kind of present in one figure itself, right? Now if I want to see and from this particular thing itself, you can also see that the range of CumSum is varying a lot. It is from around -70 to 10, whereas our range of values will be in between -3 to 3, because we have just used random right here, standard normal distribution. Now, what if I want to use two different subplots for these two different values? For doing that, what you can do inside your df.plot function or attribute, you need to pass your subplots option as true, and you need to pass the figures. You can also pass the figure size. For example, I want to increase the figure size of this particular plot, so I am passing the figure size of 15 cross 7. So 15 will be my length and 7 will be my width. So now if I run this particular cell, here you will see two different subplots are now present for each of the column inside my data frame. CumSum is again different from this particular thing, and by using figure size, I'm also able to increase the size of my plot, right? With other modules packages for plotting like Plotly and PyPlot, is Matplotlib enough, or we should master others? If you are great with Matplotlib itself, there the other or you can the syntax of other libraries like Plotly and couplings, all the syntax kind of matches with the Matplotlib itself. So if you are good in Matplotlib, that is enough. Dennis Gitari. And Anonymous, can you explain how to plot using calendar? I don't know which calendar you're talking about. So yeah, now moving on to the next thing. So this was simple line plot, right? Now there are other types of plots also present inside this pandas profiling or pandas plotting. For example, in this particular cell, I want to I am plotting a histogram plot. So for doing that, what you can do, you just need to pass this particular kind of argument as hist. So it will automatically Python will automatically understand that okay, this particular data frame is coming, and subplots are true, and or type of my plot need to be histogram. So if I run this particular cell, here you can see the histograms for both the both the columns, CumSum and value. Histogram is basically your plot of values versus frequency. How many times a particular number or a particular number from a range is repeating in your total data. That is your histogram. And by looking at the histogram, you can also tell about the distribution of your data, how your data is distributed, right? And many more. Or if you see this particular thing, let's run an error. Many more. I guess bar chart is also present inside this kind thing. It will take a lot of time because in plotting bar chart, that will be seeing one of the each of the numbers. So it will take a lot of time plotting the bar chart. Yeah, seaborn can also be used. right? So here you can see bar chart for each number that is present inside our data sets itself has been created, right? And if you press shift tab here in this particular function, you will see the doc string of this function, and inside that you can see different kind of plots that are present inside it. So we have seen the histogram plot and our bar chart, right? Now let's move on to the next part, or let's see how PLT thing that in matplotlib.pyplot I have imported as PLT. How does that particular thing works, right? So for this particular thing, first of all, I am importing seaborn because there are some of the data sets, some of basic data sets present inside that seaborn. So I'm going to use those particular data sets for this session itself. So I'm importing seaborn as SNS. And from that seaborn library, I'm loading the data set of iris flowers data set. So basically this iris data set is of different flowers, and their sepal length and petal length and widths, all those things are present inside this iris data set. Let's import this particular thing. So if you see here, this iris.hat is basically showing first 5 values from your data frame. So sepal length, sepal width, petal width, and species. These 5 things are present inside your iris data set. That, okay, if the sepal length is this particular thing, sepal width is this, then what is this species? And if you see, let's see this particular thing also. Iris this. So 3 different type of species of flowers are present inside this data set. Your Virginica, versicolor, and setosa. And information about those things is present inside this particular data. 4 times which model, naive forecast, extra statistical method, which package mostly used. For time series model, generally the stats model package is used. Subramanyam. Or you can also use deep learning techniques like RNN, recurrent neural network, or LSTM, those things. But if you want to use a remand simple statistical method, then stats model package is good. Now let's again use our by default. First of all, see our by default plotting that is provided by pandas. So here, when I used iris.plot, you can see the different columns of this iris data set has been plotted. Our red is representing petal width, green is our petal length, orange is sepal width, and blue is your sepal length. Now, by seeing this particular data, first thing that we can see or get information about is about the range of your different data columns, right? For example, the sepal length, if you see the sepal length, the range of your sepal length varies from 5 to around 8, right? And let's assume these are in centimeters. So your sepal length kind of varies from 5 to 8 centimeters, right? And your petal width varies from 0 to 2 centimeter only. And if you see the petal length here, there is a lot of variation in your petal length, right? It starts in the range of your petal length. It is starting from around 1 and going till 6, right? So these type of initial observation you can get by just visualizing the data, right? Okay, that what are the different range of my different columns, right? And how one column is correlated with the other, all those things you can get, or you can understand about your data, right? And again, we are using subplots itself. So yeah, we are plotting different columns here. Now, how to use plt.plot or plt library itself, right? So first of all, I'm going to talk about line plot. So for plotting a line plot, if I want to plot 2 variables on x-axis, for example, on x-axis I want sepal length, and on y-axis I want sepal width, and I want a line plot of them, right? So I can just use plt.plot function of your matplotlib plot function, and inside that, at the first argument, I will pass the values that I want at my x-axis. So on x-axis, I want sepal length, right? So I have passed iris sepal length. And on y-axis, I want my sepal width, right? So you can also say that this is a kind of a bivariate analysis, because we are using 2 variable here, right? Sepal length and sepal width. And now when I'm going to hit this particular cell, here you can see a line plot has been created, but it is kind of meshy, right? Because different points are kind of representing different points from this particular data frame. So I am not able to kind of understand this particular plot. So instead of line plot in this particular cell, in this particular thing, instead of line plot, I can just use scatter plot itself, right? So instead of plot, I need to use plt.scatter. And when I'm going to run this particular cell, you can see the scatters. Now here on the x-axis, your sepal length points are present, and on the y-axis, your sepal width points are present, right? There is not a direct relationship between these two. But if you see, there is a kind of little bit, not a lot, little bit linear relationship, right? For if we see this particular cluster itself, when my sepal length is increasing, my sepal width is increasing, right? If you see this particular thing, or give me a second, let me connect my notebook here. Yeah. So if you guys see here at this particular point, there is a kind of a linear relationship, right? So all these things we can visualize in our initial stage itself, right? So this is our scatter plot, basic scatter plot, or you can say point plots for visualizing bivariate, for doing bivariate analysis, right? Now, same thing here, we were visualizing the relationship between sepal length and sepal width. And in the next step, I'm kind of seeing the plot between sepal length and petal width, right? So this is, again, here we can kind of see a linear relationship type of thing, right? Now, what if I want to plot these both scatter plots in one figure itself? For doing that, what you need to do in one self itself, first of all, you need to write the first plot that you want to plot, right? For here, for example, here in the first slide, I have written that, okay, I need a scatter plot between sepal length and sepal width. And in the second line, I have written that I want a scatter plot in between sepal length and petal width. Now, if I'm going to run this particular cell, you can see that both the scatter plots are plotted in one figure itself, right? But we don't know which color is representing which one, right? That particular thing comes in your beautification or customizing your plots. That again we will see in the next few seconds. But if I want to change this particular scatter plot into a line plot, that particular thing, sorry, not line plot, I've written P plot itself. So that particular thing is also possible here. So you can also plot different kind of plots itself in one figure, right? This thing clear to all? Let me see some questions. You could use a better business example for visualization. Yeah, Nishant, but this is kind of a session for beginners, I guess. That's why I'm using these data sets. Again, Subramaniam, this is for a visualization session, but the question that you are asking, that particular thing can be, you can use scikit-learn. There is this sklearn library that can be used. Right, so let's move on. Now, our next step will be beautifying the plots, right? We have made this particular plot, but I'm not able to see that what is my x-axis representing or what is my y-axis representing, right? And I also am not able to tell that what are my orange points and what are my blue points. So let's beautify our plots, right? So first of all, we will start by labeling our x-axis and y-axis. So what you can do, these particular two lines are similar to this particular thing. Now, for labeling your x-axis, we all know our x-axis is nothing but sepal length. You can use xlabel function that is present inside your Matplotlib. You can use this plt.xlabel and just just pass the name that you want to label on your x-axis, right? So I'm labeling my x-axis as sepal length, and in a similar way for labeling my y-axis, I'm using widths, right? Because both of these things are widths. One is sepal width and other is petal width. Now, when I'm going to run this particular cell, you can see your x-axis now sepal length, this particular thing is present, and sepal width is present. Again, you can customize it a little more by providing the color itself. So for example, I pass the color of my X label will be red. And also you can also pass the size itself by S. Okay. So here you can see I pass size argument as 20. So this X label has been increased, right? Now our next step will be adding grids, right? Why adding grids? So by adding grids, it will kind of become easy to understand that, okay, when my point is 5, this particular point is representing. Is it around 1 or is it around 1.5? As this particular data set is a very basic one, so we are able to tell that, okay, yeah, this is around 2 or 2.5. But for a complex data set, for example, you have 2,000s or 10,000s of rows. In that particular thing, you will not be able to directly tell from the plot itself. So in those purposes, grid also comes into picture. So by adding grids, you will be able to add these vertical and horizontal lines, right? Now, in my next step, I will be adding legend to each of the plot. Legend is basically, it will tell that, okay, what my orange point is representing and what my blue scatters are representing. So for doing this, what I'm doing in my scatter code itself, I'm adding that, okay, this sepal length and sepal width, the label of this particular scatter plot is my, or this particular scatter points is sepal length versus sepal width. And for the below one, the label is my sepal length versus petal width, right? These two labels has been added. And apart from that, I'm also adding this particular line plt.legend that will kind of, let me first of all run this particular cell. Now this plt.legend will add this particular information about your scatter points, that, okay, your blue scatters are representing sepal length versus sepal width, and your orange points are representing sepal length versus petal width, right? And this LOC is basically your location. Where do you want a location of this particular box, right? So currently I have written upper right, but you can, if you remove this LOC part itself, so it will automatically place your location at the best point, whichever spot is best for that particular location, or whichever location is kind of hiding less number of points, right? Now we have, what we have done, we have added grids, we have added X labels, Y labels, we have added legends. Now let's change the size of plot, because it is kind of a little bit smaller, right? So for changing the size of plot, all the other commands will remain same, but at the starting of your plotting itself, you just need to write plt.figure, and inside that need to pass the figure size argument. And here you can pass whatever size you want to see. For example, here I have passed 16 cross 10. So 16 will be the length of my plot and 10 will be the width of my plot. So here you can see, right? Now let's change it a little bit, because it is going a little bit out of our screen. So this is my 15 cross 8 plot, right? Now these things has done. Also, you can also change the color of your scatter points and size of your scatter points itself. You just need to pass these arguments, S representing your size, C representing your color. So I've changed the size of the first one to 25 and color to blue, and the size of the second one to 50 and color to red. Here you can see different size. And guys, these all things that we are doing, these are kind of used for understanding the data itself, right? So I'm just telling the basic things, but when you have the real data and you know all these particular plots or all these particular tricks, and you are doing your AD exploratory data analysis part, you will be able to get a lot of information from your raw data itself, right? Now, in the next part, we are just adding the title. For adding the title, you can just use plt.title, and I have added the title as sepal length versus width. And here you go, your title has been also added. And you can also kind of change the styles of your plotting, right? This is your by default normal style. Inside your Matplotlib, there are different styles available. You just need to write plt.style.available, and it will give you a list of different styles. And from these particular styles, you can use any one of them. For example, here I am using my classic style for plotting. So I'll just define that, okay, plt.style.use, use the classic style. And here you go. This is your final plot. So we started from a very basic plot, right? From this particular plot. And our end result of beautifying the plot is this particular thing, right? So we are clear till this point, right? Is there any restriction on which color to use? No, there are no restriction. You can just pass the hexagonal code of any color and you can use. Okay, so this is our final code. I'm also copy pasting this particular final code inside the chat box itself. Okay. Yeah, Pankaj is saying, can you take one large data now and show now? Maybe in the last, if we got some time, I will take a large data set and show you some of the plots, right? But yeah, before that, let's move on. Go back to styles. Here are your different styles, and this is the code for getting your styles. Right now, let's see the line plot itself, right? Because when we saw the line plot earlier for this particular data set, that was kind of giving some messy things, right? So for this particular thing, I will be doing the same thing. I will be beautifying the plot, right? But the data I am again creating myself. For the x-axis, I'm creating a numpy array linear by using the numpy linspace function. I'm getting the array starting from 0 till 4 pi and having 1000 points, right? This particular cell is kind of creating your numpy array, having 1000 points starting from 0 to 4 pi. Y variable will be my sinusoidal curve of x, sin x function. Z variable will be my cos function of z, x, right? And all other things will remain same itself, but instead of plt.scatter, now we will be using plt.plot. And here, if you see above, I used S attribute for assigning the size of scatter, right? Now, if you want to change the width of your line, there is this LW, line width attribute present inside your plt.plot function that you can use for changing the width of your lines, right? And again, I think this particular thing I copied from above itself. Let's change the title also, sine and cos. And on our x level will be, let's say, x values. Y label will be sine and cos. Let's just hit this cell. So here you can see your line plot itself, right? Now you can also change your line plots also. You can also kind of change the style of plotting. For example, this particular blue line, this sinusoidal line, instead of this sinusoidal line, if I want kind of dash lines or bash lines, that particular thing you can also do. For example, in this line of code, if you see plt.plot, I am passing my x values and y values. And after that, I am passing that, okay, I need this particular styling here, right? So if I run this particular cell, here you can see your line has been converted into your dashed lines. Again, depending on your business case or different things, you can use this particular customization in the plots itself, right? Now, coming on to our next type of plot, that will be histogram, as we discussed earlier itself. So it will kind of give us estimate that how many time a number is occurred in a particular data. And by that histogram itself, you will be able to understand the distribution of your data, right? I'm not going in depth of the distribution because again, that is again a different topic for different discussion. There are different distributions present. So for seeing or for visualizing the histogram of a particular data or a particular data column, you can just use plt.hist function, and inside that just pass that particular data set of which you want to see the histogram. So here I'm passing what is my distribution of sepal length. So here you can see the histogram of your sepal length. So it is basically denoting that for this particular interval, around 9 points are occurring in my data set. For this particular interval, around 24 points are occurring in my data set, right? And again, in a similar way, as we discussed earlier, we can also plot two different figures itself. We can also plot two different plots itself in one figure. So here I'm plotting the histogram of sepal length as well as petal length, right? Again, but I don't know which one is which. That thing you can do by adding the label thing here and using plt.legend, right? The same thing we can directly be done by using the data frame itself by using df.plot, or here my data frame name is iris. So iris.plot, inside that just pass kind. You can pass the kind that histogram. Okay, so all the different histograms of the columns that are present inside your iris data set are plotted in this particular figure that you can see. Again, if you do the subplots as true here, so you can see different plots also. Now you can also change the bin size. So basically bins are these particular rectangles that are repeating, right? So if I represent bins as 100, I want 100 bins. So here you can see bin size has been changed. So when we changed the bin size, so when we increased the bin size, your interval that we were taking earlier, that has kind of decreased. So it is kind of now showing that for a point from 0 to 0.1, let's assume this particular point is 0.1, around 5 points are present. So in this particular way, you can also change your bin size itself. And here, let's change it into 1000. Now more minute detail can be seen, right? So in this way, you can play around with the histogram itself. And again, here I'm changing the bin size to 100 and my subplots are true. So different subplots you can see here of histogram, right? Great. Now, next is our pie chart. Pie chart will kind of tell us that, okay, in a particular distribution or in a particular data, how much percentage of one thing is present. For example, let's see this particular data itself. So what I am doing here, I am kind of getting my first line from this iris data set by using .ilog function, right? And first of all, let's remove this particular thing. Then I will tell. So if I see this data, right, here you can see my sepal length, sepal width, petal width, and species is setosa. And here I'm using this till -1 because I don't want this species to be present when I'm going to pass this particular thing inside my pie chart, because that is going to throw me an error. Because if you see here, setosa is your object type and all the other things are your numerical type, right? So we will not be able to kind of visualize that particular object in a pie chart itself, right? Now, when I'm going to hit this particular cell, it will give me the percentage, kind of percentage that, okay, if I add all these numbers in that particular thing, if we are going to add all these numbers, what percentage of my sepal length is present, right? So if you see sepal length is 5.1, and I am assuming that the sum of all these numbers will be around 10. So around 50% of my sepal length is present in this particular data set, right? That's why you can see around half of my circle of the pie chart is of blue. Then sepal width is 3.5. Here you can see. In this way, you can kind of see the different proportion of your data set, right? By using this pie chart. Our next plot will be box plot. Now, this particular box plot is a statistical plot. First of all, we will be plotting this particular thing, and then I will be telling what this particular box plot represents. Let me open my whiteboard itself. So yeah. So box plot, basically your box plot look like this particular thing. So basically your box plot kind of gives you a hint about the statistics of a data. For example, let's assume I have a data X, right? Or we can say this X is kind of age of students in a school. Age of students in a school, right? Now, if I'm going to plot a box plot of this particular X, it will give me a statistical information about this particular X, statistical information. And what are those statistical information? Basically, there are these 5 data points present inside your statistics, your minimum point, your maximum point, your median, your first quartile, or you can say 25 percentile, and your 75 percentile, right? By seeing your box plot, you will be able to tell that, okay, what is your minimum value for this particular data, what is your maximum value, and at what value 25 percentage of the data is lying, right? This is that particular thing. And what is the median of your data, or you can say 50 percentile of your data is lying at which point, and 75 percentile of data is lying at which point. And by seeing this particular box plot itself, you will be able to understand the distribution of your data. Now, if this is a kind of symmetrical box plot, so this will be kind of representing a normal distribution itself, right? And also in some data points or in some variables inside your data, there will be some outliers present, right? So those outliers will be visualized by these dot points that again will be seeing in this session itself. So those outliers will be represented by dot points in box plots. And by visualizing the box plot itself, you can also define or program a rule for removing these outliers before feeding it inside some machine learning algorithm or something, right? So here I am plotting a box plot of my petal length. So here you can see your minimum value is around 1, maximum value is around 7, and my median is lying in between 4.5 or something, right? And my 25 percentage of data is lesser than your 1.5. Let's assume it's 1.5, right? And my 75 percentage of data is less than 5. So all these things you can visualize by how are the outliers defined. Again, the outliers that I just told you, sorry, that the outliers that I told you are in ideal condition, but again the outliers again will be dependent on your use case and problem statement itself. For example, there can be a situation or there can be a variable, again depending on in which domain we are talking about, right? So let me give you an example in oil and gas industry itself, right? So let's take an example that we have the data for oil production from a particular well, right? And I am plotting that data in a box plot. So there can be a chance that it can show that, okay, there can be a chance that oil production from a well is 0, right? But box plot will be able to tell me that, okay, this 0 point is outlier because it is not lying in the normal distribution itself. But if you are a petroleum engineer or any engineer or whatever domain we are talking about, you know that, okay, yeah, this particular variable can take this value. My oil production can take 0 value. So it is not an outlier. You know that, but your box plot can show that, okay, this is an outlier. That's why this outlier, there is no such definition of outlier. That completely depends on your use case as well as in which domain we are talking about. How can Yeah, Jupyter notebook will be shared with you. Now, our next plot is scatter matrix. So this particular plot is used for doing the comparison of all the data inside your data frame, right? So scatters of different features will be plotted, and histogram for the same feature will be plotted. So first of all, from pandas.plotting, I am importing this scatter matrix function, right? Or I have already imported pandas as PD. So I can just use this pd.plotting.scatter matrix. Inside that, just pass the data frame for which scatter matrix you want to plot. Pass the figure size, color, and alpha value. Alpha value will kind of give me that how much damage in the points I want. So here you can see this is your particular scatter matrix. So by looking at these plots, you can just see visualize the relationship between different variables. If we see this petal length and sepal length, so sepal length is increasing with petal length, right? Here you can visualize this particular thing. Again, petal length is increasing with petal width itself. So all these things you can visualize with this scatter matrix. And on the diagonal thing for the same, for example, this sepal length versus sepal length, you can directly see the histogram itself. So instead of plotting different plots, all these things can be visualized in one plot itself by using this scatter matrix. Yeah, Poonam Chaudhary, you can write your question in the chat box. No need to worry, Spring. I will post the link of the notebook from my GitHub itself in the chat box later on in the session. Now, this was kind of basic plots. Now, the next thing that comes into picture is dynamic plotting, right? So these are static plots, right? Nothing is moving and kind of static itself. Now, there can be a scenario, there can be a use case for you. For example, there is some variable that is changing, right? Or let's take this example itself here. So here what I'm doing, I'm importing this interactive function from ipy-widgets. So these ipy-widgets is a library by default that is by default present inside your Jupyter kernel itself, right? From that library, I'm importing this interactive function, right? And what I'm doing here I'm writing a function whose name is power, and inside that argument of n will pass, right? And what will this function do? This will basically, first of all, it is making a points between -5 to 5, and it is making 100 points. Let's take 100 points between -5 to 5. And it will calculate the value of y at nth power. It will calculate the value of y as x to the power n. Here, if you see, I'm telling that, okay, my y is equal to x to the power n, right? And after that, it is doing nothing but plotting my y x versus y, right? And from this function, I'm taking the return of x and y. Now, what I can do, I can make this particular thing dynamic. How? By using this interactive function. So I just need to write this interactive here, and inside that interactive function, I just need to pass the function which I want to make dynamic. So I want to make this power function dynamic, right? This power function. So I pass power here, and after that, I just need to pass the values of n, or value of arguments. Here n is my argument, right? What values this n can take. So I have passed that, okay, it can take the values from 0 to 8. Now, right? Now, when I'm going to run this particular cell and when I'm going to run this W, here you can see your dynamic plot has been created. Now, when I'm going to change this n, your plot is changing. For n to the power 0, when n is 0, your y is x to the power 0, right? And it will be a straight line. All values will be corresponding to 1. When n is 1, your y will be y is equal to x to the power 1, right? And the straight line here, y equal to x. When n is 2, y equal to x square, x cube, x to the power 4, 5, 6, 7, 8. And one more thing here, not only one argument, you can pass multiple arguments itself. For example, I'm also passing m here, and that m will be added inside this y function itself. And let's also give the value of this particular m from, let's say, 10 to 20. Now, if I'm going to see W. So there will be two different things for N and M, right? Two different cursors. So you can play around. Again, this particular thing you can use in your different use case or in your different application itself, right? No, it is not advisable to always remove outliers before you are sure that, okay, this particular thing is outlier, right? Again, that will not be not only with the data visualization thing, but with domain knowledge also. You need to tell that, okay, if a particular point is an outlier or not. That's why I always say data science is just a tool. It's not a complete domain, right? Data science is just a tool that you can use to solve different problems in different domains. You need to have the domain knowledge for the problem statement that you are solving. Okay, what else? Yeah, great example, Jos. With the dynamic, this particular dynamic plot, you can see which curves fits better at your data. Ankit, again, this is for this session is kind of for plotting itself. If you want to know about outliers treatment, we can again connect offline. I will provide my LinkedIn details later in the session. Right now, let's come to our next part or our final part of this particular session, that is seaborn library. Again, this seaborn is Python data visualization library that is built on your Matplotlib itself, but it kind of provides a high level interface, right, for getting some of the statistical information about your data. And again, we were using the seaborn data sets itself. So for seeing all the data sets that are present inside your seaborn, you just need to write sns.get dataset names. So these are some of the basic data sets that you can use for practicing around initially in your initial phase of learning, right? So here, for my next step, I am using the tips data set from the seaborn itself. So this tips data set is basically the data set for different value of tips given by people on a total bill, and what was the sex of those people, and were they smoker or not, and what was the day, and whether they had dinner or lunch, and how many members of their family or how many people have gone in that particular restaurant. So this tips data set is basically a data set of a restaurant, kind of showing different tips. Now, one of the use case that you can do from this particular thing is by using machine learning, you can estimate that what will be the tip if what will be the tip depending on the total bill, sex, smoker, day, time, and size, right? So now let's do some visualizing thing first. So our first plot in seaborn will be rel plot. Again, you can say that this rel plot is nothing but the scatter plot of seaborn, right? It is a fancy brother or fancy cousin of scatter plot that has went to US. And however we can use this rel plot, we can see. So just write sns.rel plot. Again, on x-axis, what do you want? On y-axis, what do you want, right? For here, I want on x-axis total bill and on y-axis tips. So here you can see on x-axis is my total bill, on y-axis is tip. Again, a linear type of relationship you can visualize. But what happened in scatter plot was you were only able to do a bivariate analysis, right? But in rel plot, you can use multivariate. You can kind of visualize multivariate analysis. How? For example, here I can add one more thing, hue. That is kind of representing the color of these particular points. And I'm saying that, okay, my hue will change with time, right? And now if I run this particular cell, here you can see my time is lunch and dinner. My blue points are representing that, okay, this particular point is representing for the lunch time, and the bill was around 35 and bill tip was around 5.5 or 5.6 something, right? So I have added one more variable here in the visualization, right? Earlier it was only total bill and tip, but I have added time itself, time also, that, okay, So the people who has given this particular tip and total bill were having dinner or lunch. Now I can also add one more variable by using this style input. Here I'm passing that, okay, my style of these particular pointers need to change with this, whether the person is smoker or not. Right, and also this from this particular thing you can see this thing that, okay, the bill, that maximum tip is from the maximum bill itself, right? The person who had the maximum tip has given the has the maximum bill, has given the maximum tip, and that guy has arrived during the dinner, right? Here what I have added that whether the person is smoker or not. So here you can see the style of points has been changed depending on that person is smoker or not. If that person is smoker, then your scatter will be around, and if he was not a smoker, he or she was not a smoker, then it will be a cross. So if I see the maximum bill was paid by a smoker, and here hue I have changed with the day, right? And he has came on Saturday, and from the above graph I noticed that he has came for the dinner. So three information by just visualizing the plot itself. Maximum tip given by the maximum bill guy, and he was a smoker, and he came on Saturday for dinner. Right, in this way you can build the story around your data by visualizing visualization itself. So this was the fancy scatter plot of our seaborn. Now coming next, our next plot is count plot. So basically it will kind of just give me the count of different variable. So for example, I'm using the count plot for getting the count of my sex type, or how many total number of males and females are present inside that particular data. So here you can see around 160 male were there, and around 80 to 90 females were there. Right. In a similar way, you can also point out that what is the percentage of smokers and non-smokers by using this count plot itself. Right. So around 90 to 90 were smokers and 150 were non-smokers. You can also visualize tips, right, for different days. That, okay, what were the tips given at a particular day, right? So from this particular thing you can see that less number of people has came on Friday, right? So in this way your count plot can be used. Now our next thing is how to do analysis between categorical and numerical values, right? So for that, categorical plots come into picture. So for example, here I'm doing an analysis between my day, that is your categorical value, and another variable is my total bill, that is my numerical value, right? So from here, you can just see it has kind of plotted the total bill versus days, right? That, okay, on Thursday the maximum number of bill was around or maximum amount of bill was around 42. On Saturday maximum amount of bill was around 51. On Sunday maximum amount of bill was around 49 and 48, something like that. So in this way you can kind of visualize, or you can get a relationship between your categorical as well as numerical value, categorical versus numerical value, by using this categorical plot. Right, and here again I'm doing the visualization with respect to smoker versus total bill, right? So next plot is box plot from our seaborn. The very basic box plot we had already seen from our Matplotlib. That was kind of a very basic one, right? The seaborn kind of again provides some of a more functionality in this box plot, right? So first of all, I'm going to see a simple box plot of tips and days. So I have passed two variable, days and tip itself, right? So on the x-axis is day, and on y-axis is my tip value. So it is kind of telling me the distribution, or telling me the telling me the statistical approach, or minimum, maximum, or median, all those values for different days tips. Now you can say that, okay, these particular things are outliers, right? From visualization you can say, but again, whether they are outliers or not, that completely depends on your use case. Right, so in this way you can use your box plot. So in seaborn, what different functionality is there, that, okay, for each different day, or for each different categorical value, you can also plot a box plot for your numerical value. And here, one more thing I can add, that is hue. Again, my color, that my hue is changing with respect to sex. So here, if you see, with respect to day itself, as well as with respect to whether a guy is male or female, we are again able to see the distribution of our data, right? So if you see this particular thing on Thursday, females, the median of female tips is kind of lower than the male tips. On Friday, median of the female tips is kind of higher than the male tips, right? So in this particular way, you can kind of again get some informations about the data from using this box plots itself. Now, a joint plot. This is kind of scatter matrix itself of seaborn, right? But it will only give you a scatter plot and histogram for one variable, for two variables only, right? So again, it is my tips value, right? I'm using SNS dot joint plot here. So here you can see these particular things are my distributions of tips. This particular thing is a distribution of tips, and this particular thing is distribution of total bill. And here in between is your scatter plot. So this joint plot is nothing but a combination of your scatter plot and histogram, right? And this pair plot is your complete, that particular thing that we already see earlier. Histograms for the same values and scatter plot for the different variables. Now, the last thing that comes into picture, you can also fit a regression line for data points by using a seaborn library, right? So inside seaborn library, there is this LM plot that will fit a regression line for your data points. So you can also say that kind of doing a small linear regression type of project by using seaborn only. No need to use scikit-learn or anything. You just need to use the sns.lm plot, whatever things you want at x-axis, which thing you want at y-axis, right? And data, I'm just passing that I'm using tips data. So if I'm going to run this cell, here you can see it has kind of plotted a regression line itself between my total bill and tip. And by seeing this particular regression line, you can just tell that, okay, what will be the value of my tip when my total bill is this? A simple linear regression application by using plotting only, nothing else. Right. So here I have just used tips and total bill itself. Again, you can also do it by day wise itself. For example, here I have passed that, okay, column, I want days. So for different days, you can plot different linear regression types that, okay, if a guy is coming on Thursday and his total bill is 40, so his tip will be around 6 rupees. If he's coming on Friday, then it is around 4.5 rupees. In this way, by using one more variable itself, you can kind of do this particular regression thing. So yeah, guys, that's all from my side, a basic or brief introduction to plotting. Again, first of all, let me share this particular notebook to you guys. So it is present at in my GitHub repository. And the previous notebook is also present in this particular repository itself. This one is from my previous session from Numpy and Pandas. It's loading, it's kind of heavy, a little bit heavy. This is from my Numpy and Pandas session notebook. And for this particular session is this notebook. Pasting it in the chat box. And this is my GitHub profile. If you want to see more projects or more things, kind of maintain different repositories, you will get to know about all the repositories. I have a complete Petro NumPy course itself. And also, if you want to, as this session was for 1 hour itself, if you want to go a little bit in more detail, if you like this particular session, you can also subscribe to my YouTube channel, Petroleum from Scratch. Here itself, I kind of teach different data science things, or different data science algorithms, plotting and all those things, statistics. So you can also subscribe to my channel also. I'm also sharing this link. And for connecting me on my LinkedIn, this is my LinkedIn profile. I hope you guys enjoy the session itself, and all these details are again itself present in this notebook itself, right?
Thank you very much, Jayesh. I really enjoyed your session. Even I'm also a learner, and I am learning these all things. And I really amazed by seeing the concept you are teaching about outliers and beautifying the concept of the graph. So I really amazed by seeing your way of teaching, and I hope our audience also enjoyed your session. And we will conduct such more sessions with you for the coming days. Okay.
Yeah, okay, thank
Hope
you. And
we
guys, it is the time for the question answers. You can post the question answers.
yes. Just meanwhile, we have some questions in the Q&A sections.
Yeah, I
Few
will see
questions
that.
we
Give me a second.
already answered, and few are left.
Okay, someone is asking the plots are not there, right? Because when I uploaded this file, if you see, I haven't run the cell. If you download this particular cell and run in your local system or on your collab system, the plot will kind of appear. So no need to worry about that. It's just code things. Plots are not present there. If you want me to upload this particular thing also, that I can also upload it. Give me a second. Plots. Okay, so the plots file has also been uploaded. Let me share the link to this also. And here are all the links. I'm just pasting all them together. Yeah. Now let's see the question answer session. Is it advisable to always remove outlier before using data to build models? I've already answered it. Again, depends on your use case. Would you advise normalizing or standardizing a data set to annul the effect of outliers and normalize a data set? Again, you cannot directly say that by normalizing or standardizing will kind of annul the effect of outliers. It will not. Please explain the data equal to tips variable. Okay, so what happens in seaborn? Let me come to here. So what I'm doing, I'm using this plot, right? sns.lm plot or any plot. Let's take example of which one? Okay, let's take example of that one itself. So one thing is whether I can pass that, okay, x is equal to my tips column of my tips data set total bill. And again, here y is my tips column of my tips data frame, right? And here cul is my again that particular thing, right? One way is doing this, or other way is just pass the value of x and y, that okay, my x will be this column and y will be this column, and data is I'm using tips data frame data. How to scale the y and x axis variables in the plots? I'm not able to understand this question, Sanjay Kumar. There are for scaling a particular data frame, there are min-max scaling and standard scaling present inside your scikit library that you can use. But why you want to scale at the first place itself, or in the first phase itself? Yeah, IDA deals with outliers and data pre-processing, but your first phase will be understanding the data, right? You will know that okay, what is the range of my data set. If I do the scaling at the first phase itself, how would I know that okay, this particular feature from my data frame is ranging from which value to which value? Great. Okay, then share LinkedIn link. I already shared all the links. Let me again copy paste it here. Okay, then I guess there are no more questions left. It was a great session, guys. I hope you all enjoyed it.
Thank you very much, Jayesh. Really, I enjoyed your sessions, and I hope
Thank you.
the participants also enjoyed your session. We will meet you in the next session, Jayesh.
Okay. Thank you all.
Okay,
Thank
Jayesh.
you. Have a good day.
Bye-bye.
Happy learning. Bye.
Bye. Bye-bye.